Harshjit, can you unmute yourself?
Hello, sir. Good evening.
Good evening. So your question is?
Yeah, I have a dot in activity 2.6, question number 6, and activity 2.7, question number 7.
Okay. Just a minute. So, Harshjit, can you repeat your question? 2.6, question number 6.
Yes, sir. 2.6, question 6, and 2.7, question
I'll
number
come
7.
to next question. So, first, let me explain you. Okay, so what is your problem in 2.6, question number 6?
Sir, actually, I couldn't get the answer.
No, like, can you tell me where basically you are facing the problem?
Sir, when I calculate, actually, sir, I don't know the formula of tan theta that is basically given in the option 1 and in option 3.
Yes. So basically the question is, you have two lines with slope m1 and n2, and inclination is basically alpha 1 and alpha 2, and it is given that your alpha 1 alpha 2 is basically greater than alpha 1, right?
Okay.
Mm, and intersect each other and make an acute angle theta and obtuse angle alpha. Then which of the following statement basically are true, right?
Okay.
So as you can see, the second option is not correct, right?
Yes, sir, because it is a perpendicular.
Yes, right.
Mm.
So now basically what you have two lines. So
ये नहीं है ना वो कैमरा में ऑन नहीं है ना
so right, and
Okay.
one of the angle is alpha 2 and one of the angle is
alpha 1.
alpha 1, right?
Okay.
So your this angle, this is basically alpha 2,
Minus alpha 1.
right?
First, I want to discuss all this because we understand that it opens up a
So
lot
can
of
you
problems
mute?
that we as developers and technology.
Sir, actually, it is not from my side.
Okay.
So let's go with a very common problem.
Oh, thanks. So then this basically is your theta, right?
Okay.
And this is basically your
Phi.
phi, right?
Okay.
And phi is basically your 180
Minus theta.
theta, right?
Okay.
So then what is your tan theta?
Tan theta is equal to tan phi is equal to tan 180 minus theta. Basically, it is a minus cot theta, I think.
Right?
Okay.
So now what is the formula of tan A minus B?
1 plus tan A. 1 plus tan A tan B upon tan A plus tan B.
1 plus
1 plus tan alpha tan B tan alpha 1 tan alpha 2 upon tan alpha plus tan beta.
yeah. So basically this is basically tan alpha 2 minus tan alpha 1, right?
Okay.
By what will be the
Sir, actually, I don't remember. I'm little bit confused about. Actually, I told it's opposite. 1 plus
yeah,
tan alpha into tan beta upon
yeah,
alpha.
basically see the formula is basically what? See, let me write the formula first.
1 plus tan alpha multiplied tan alpha 2.
No, this is basically tan alpha
Hmm.
2 into tan alpha 1. Is it correct?
Okay, actually, I told it's reciprocal.
See, tan A minus B, which is basically what? Tan A plus minus B, which is basically what?
It is a
Tan A plus
tan B
here B is minus
minus
B
B. Yeah, it is tan upon
divided
1
by 1 minus tan A into tan minus B. And your like tan is basically tan of minus A is basically minus of tan A, right? So
Okay, sir.
that you can write right.
Okay.
So now if you see the question, your tan of alpha 1 is basically m1, right?
Okay. Yeah, right.
Correct?
Okay, correct, sir.
So basically what you are getting, tan theta is basically m2 minus m1 divided by 1
1.
plus m1 into m2, right?
Right.
So then in the first option it is given that tan theta is so can you like I don't know, like can you unmute who is that person? Just a minute. Can you tell me who is actually from who is basically what this particular noun is coming from whom? I'll mute that person.
So it's Bravis Ghosh, I think.
Okay, yeah, I think he unmuted, muted himself. So yeah.
Sir, actually, I'm not able to see your screen.
Yeah. Now I'll share my screen. So actually, I wanted to mute that guy, so that's why.
Okay.
So now it is visible, right? So
Yeah, it is.
so the first of now you can see like the first option is correct, right?
Okay.
Because see, you are getting tan theta is basically m2 minus m1 divided by 1 plus m1 into m2, right? And certainly this is not equal to m1 minus m2 divided by 1 plus m1 into m2, right?
Yes, sir, it is.
So the first option is not correct. And your fourth option is correct, because what is your theta? Theta is basically alpha 2 minus alpha 1. So tan theta is basically
Sir,
tan of,
sorry, sir. Please repeat option 1.
no, see, what is your option 1? Option 1 is basically saying tan theta. Okay.
Okay.
So what is your option 1? Option 1 is tan theta is tan of alpha 2 minus tan of alpha 1
Okay.
divided by 1 plus
tan alpha 1 into tan alpha 2.
and we got some value of this quantity, right? What is
Okay.
this?
Okay.
This is your m2
M2
minus m1
M1
divided by 1 plus m1 into m2,
M2.
right? And
Okay.
this is certainly not equal to m1 minus m2, right?
Okay.
So the first option is correct, right?
Okay.
This is what this is particularly like, yeah, this is the first option, right?
Okay, sir.
So this is correct, right? Is it clear?
Yeah, it is clear now.
So now you have alpha, right? Alpha is basically what?
Alpha is
sorry, not alpha. You have theta. Theta is basically what? Alpha 2
alpha
minus
2
alpha
minus
1.
alpha 1.
So tan theta is basically what?
So tan alpha 2 minus tan alpha 1.
So
Yeah,
third option
got
is
it.
correct.
Okay.
And how you will do the, sorry, not this is not third option. This is fourth option. Yeah.
Okay.
So what about third option?
So tan phi
You know
tan phi is,
yeah, you know the value of tan theta, right?
Okay.
You know the relation of theta and
And phi.
phi. Now you just use that formula and you will get the answer.
Okay, sir. Okay, I will do it.
Yeah, it's easy. Like you can do it, right?
Okay. Sir, I'm a little bit confused about the formula of like this tan alpha 2 minus.
Okay, that is fine. That you can you
Okay.
can see. But the idea is basically, yeah. So you have some relation and you have to use that relation to get the answer.
Okay, sir.
So is it
And then,
clear now, this question?
yes, sir, it is clear.
Okay.
Next is 2.7, question number 7.
Question number 7. Yes. Yes. So yes. So what is your problem here?
Sir, how is its answer is option D.
No, the question basically you have to choose the correct answer, right?
Okay.
So yeah, basically if you have 2 points, you have suppose x1 and y1.
Okay.
So how you will compute the equation of the line which passes through these 2 points?
Sir, it is x minus x1 upon y minus y1 is equal to m. And that is
Yeah. Yeah,
y2
so
minus y1 upon x2 upon minus x1.
yeah, so basically then your fourth option is correct, right? This is what Sir did in his lecture, right?
Okay.
If you have 2 points, then basically you want to find the equation of a line which passes through these 2 points. So basically what he did, he took a arbitrary point, and then what he showed, basically slope of this line, the line which passes through x1 y1 and xy, is same as the slope of the line which passes through x comma y
Is
and
equal
x2
x2 y2.
y2. They are basically same, right?
Okay.
So
And
then from that you will get the fourth option, right?
and what about option A?
Okay, I'll go one by one. So so now so now the third option, the equation of a horizontal line can be x equal to a. So is it correct? What you think?
Horizontal. No, sir, it's y is equal to A.
Yeah, yeah. So the third option is wrong.
Wrong. Yeah.
So for fourth option is correct.
Correct.
It's correct. So third option, this is wrong. So now
So your headphones are
is a 2 point form of a equation of a line. This can be also true.
Sir, here why not is basically it is a some fixed point, or it is a variable.
Mm, yeah, actually, yeah, whatever, like I got your point, why you are actually confused with option 2. So basically, if you have a line which passes through uh, the points x0, y0 and x1, y1,
Okay.
then the slope is basically
Y1 minus y0 upon x1 minus x0.
yeah, whatever you are saying, y minus y0 into y minus y0 by x1 minus x0 into x minus x0. So this is your basically slope,
Yeah. Yes,
right?
sir. Hmm.
So yeah, in that sense, the second option I think is correct.
I'm little bit confused about the why not is a variable or it is a fixed point.
Yeah, that is basically, yeah, I think it should be mentioned in the question.
Yes.
Yeah. It's actually, yeah, I think it is a mistake, because if you are taking x0 and y0 as a variable, no, not variable. If you are taking this as a point on a straight line, so then this can represent a equation
For
of a straight line,
line.
right?
Yes, sir.
Yeah. So yeah, we'll modify this question, okay, so that it won't create any confusion. Because I don't know, like whether like who prepared this question. I think he wants this m to be in this form, because sir actually basically mentioned in his lecture, he basically wrote that equation in this form, right? Y minus y1, that
Yes, sir.
2-point form of the equation of a line, right?
Mm.
So maybe who prepared this question, I think he wants the equation of line in this form, but certainly certainly yeah, basically it is creating unnecessary confusion.
Okay.
Yeah, we'll thank you, we'll change, we'll modify this question.
Okay, sir.
And what about first option?
First option is, let me check. Yes, sir. Actually, I have a dot in that. The question of line in
which question are you
point
discussing,
form.
sir?
It is a 2.7, question number 7.
2.7, question number 7.
Sir, I am not understanding what the option says.
No, basically, see, so you have, if you have a point, so if you have a point
Okay.
and slope of that line, then you can get equation of that line.
Okay, sir. Yeah.
And second thing is, if you have 2 points
Okay.
of that line,
Mm.
then also you can get equation of that line.
Yes, sir.
Right?
Right, sir.
So basically what this option is asking, so can you, so you have a equation here and you have a equation here, okay, can you convert that equation into,
yes, sir, y-intercept form? Yes, sir. It is converted into that.
right? This is what the first option is asking, right?
Okay.
So I think this also you can do. Because suppose you have a line which passes through.
Yes, sir. Any line which is in the form of y minus y benign.
Yeah,
I think that it is converted into intercept form. Y is equal to mx.
This can be also done. Yeah. So okay. So basically, suppose you have this line. This you have a line which passes through x naught, y naught, and slope of that line is m. So then you can write this in this form. You can represent that line in this form, right?
Okay.
Then you have y minus y naught, which is mx
Minus mx naught.
So
and
then
take mx from left hand side and y naught right hand side. Yes, sir.
so now you have mx
Plus
plus y
minus
naught.
mx
So you
naught
can denote this number
as a c.
as c. Okay. And same thing you can do for that 2-point form also. Okay.
Okay, sir.
Because basically you are getting the same thing, right? Instead of y2 minus y1 divided by x2 minus x1, you are basically getting the slope. They are basically the same thing, right? So same thing you can do. We'll change this question. Okay.
Okay, sir.
Yeah. Thank you. Thank you for pointing this out. I think this is this is mistake. Okay. So any other doubt?
Sir, actually, I have a dot in a area of triangle. Sir, how to find the line is linear or it is formed a triangle?
No. See,
So
triangle.
if suppose 3-point is given, then how to find it? The 3-point is collinear or it is a form a triangle?
See, you have 3 points, right?
Okay.
So you have, the formula for area.
Yes, sir. Half
of a
into yes.
triangle, whatever this is. Okay. So if you calculate, so if your 3 points, they are in a line,
Its area is 0.
0. Okay. But if they are certainly not collinear, then you can form a triangle, right? See, using these 3 points, you cannot form a triangle, right?
Okay.
But if 3 points are not collinear, then you can form a triangle.
Right, sir.
So then you will get a positive area.
Okay.
So basically, what you have to do, suppose you have suppose 3 points. Suppose 3 points. Try to use the formula of the area of the triangle. Okay. So if you are getting 0, the area is 0, then basically these 3 points, they are collinear. If you are getting some positive value, then certainly they cannot be collinear, right? Because in some sense they are basically creating a triangle. Okay, this is not a triangle, this is a line. Okay. This is a triangle. So if you have a triangle, then definitely you will get a positive area. If the 3 points, they are collinear, then the area has to be 0. You don't have any other choice. So by computing by applying this formula of the area of the triangle, you can say whether these 3 points are collinear or they are not collinear.
Okay, sir.
Okay.
Okay, sir. Got it. Thank you.
Okay. So now Pooja Soni. Hello. Pooja, are you there? Okay, so next one is Diksha Krishnan.
Yes, sir.
So you have some doubt in activity 2.4, question number 2, right?
Yes, sir.
2.4, question number 2. Yes.
Sir, what I did was I took. They're saying that the midpoints of the given points form the triangle, no, sir. So I took the point. I took the midpoints and I took them clockwise and anti-clockwise. I'm getting the area as 4.5, sir. And when I checked the answer, it came as 1.5. So I'm just not sure how the answer is 1.5.
Okay, so this is basically the computation. You have to do the right computation. There is no, okay, let me tell you the idea. Okay, once you have 3 points, then you can certainly apply the formula of area of the triangle, right?
Yes, sir.
So you have P, you have, so you have 3 points, P, Q, R. So the coordinates of P is 0, 0. This is 3, 0. And R is 3,
3,4, sir.
So you have, suppose this is your midpoint of P, A is basically the midpoint of P, R. B is the midpoint of P, Q. And C is midpoint of Q, R. So you are getting a triangle ABC.
Yes, sir.
So you know how to compute the midpoint of a line segment. Suppose
Yes,
you
sir.
have 2 points. So then I think rest is fine, right? You just have to do the computation. I think, yeah, I think you have made some mistake in the computation. So are you using that formula, that triangle formula that
Yes, sir. Yes, I'm using that only. I mean, I got this. I got the same figure you have drawn, sir, and I've got the respective points from the coordinates given in the question.
yes.
But then I checked it like some 3 to 4 times. I checked it again and again. The answer is still coming 4.5, sir.
Okay. You are getting 4.5. So like so can someone tell, like so any of you solve this question? Question number 2, activity 2.4.
Yes, sir, I solved it earlier.
Are you getting the same answer, 4.5?
No, sir. I guess I am getting 1.3 only.
Sir, I got 1.5.
1.5, yes, sir.
So yeah, I think, yeah, like yeah, I think you have made some mistake. Like I will suggest you to do it once.
Okay, sir. Okay,
Okay,
sir.
because see, there is nothing to do here. This is basically addition and multiplication. If there is something important to tell you, then I must have computed here. But yeah, basically there is no point of doing addition and multiplication. So
Yes, sir.
so yeah, I think, yeah, if you, so whatever you are saying is correct. Your idea is correct. Like you have to find out the midpoints of PR and QR, and then basically you will get a triangle. Then after that, just use that formula. Like you take this to be x1 and y1, x2 and y2, x3 and y3. Then you apply this formula, whatever. X1 y2 minus y1 plus x2 y3 minus y1 plus x3 y1 minus y2, and you have to take the modulus of this sum. So, so you are applying this formula, right?
Yes, sir. Yes.
Then I think you have made some mistake. Otherwise, I will check it once. Okay. If there is some mistake here, then I'll will change it.
Okay, sir. Okay.
Okay.
Thank you, sir.
Thank you.
One more thing, sir, in same questions.
Huh.
Sir, if we calculate the area of the triangle PQR and half it, will it be the same? Will it be the same as the area of midpoint, sir?
No, no. You are saying area. So you are talking about this figure, right?
Yes, sir.
So what you are trying to say?
Sir, I am trying to say that if we calculate the area of triangle PQR and half it, will it be equal to triangle BCA as it is made on midpoints of?
No. Certainly, the area of BCA is certainly less than the area of PQR.
Sir, actually, I did the same, but I guess the area of triangle PQR came to be 6, and the area of the triangle BCA came 1.5. So, is there any method or somewhat?
You are saying, is there any relation between
Yes, sir,
area
yes.
of PQR and
BCA.
BCA? I don't think so, because it's so you are expecting basically the area of PQR. Half of the area of PQR should equals to the area of BCA, right?
Yes, sir.
No. This is not true in general. Okay. So you can get some different area also. Okay, it's depend. So it's it may vary from triangle to triangle. So if you have some restriction on the triangle, then probably you can say something. But I don't think it's true in general.
Okay, sir.
Oh. So the next one is Puja Soni. So he's asking from graded assignment 2. Okay, so in this session, actually, we are not going to solve graded assignment questions. Dinesh Kumar.
Hello.
Hello. So you have doubt in activity 2.4, question number 1.
Yes, sir.
Right?
Yes, sir.
So what is your doubt here?
Just a minute. Yes, sir. I didn't get the right answer.
So you have 3 points, right?
Yes. Hello, am I audible, sir?
Yes, you are audible. So you have 3 points. So if these 3 points, they lie in a straight line, then certainly they cannot form a triangle.
Yes.
Okay, so basically you need to check whether these 3 points, they lie in a straight line or not, right?
Yes. So can I check it using area of triangle is 0?
Yeah, either you can check it by computing the area of the triangle. Otherwise, what you can do, you try to compute the equation of that line which passes through your P and R. Okay, so you have a equation. Suppose this is mx plus c, which passes through
P and
P and R. Now you just put you just check whether Q is in that line or not. You just put that y is equal to minus 20 and m minus 30 plus c. If it will give you 0, then certainly that point is in your line. That point Q is in your line. Otherwise, that point is not on that line which passes through P and R.
I have a little dilemma in my mind that if I calculate the distance between P and R, and if I calculate distance between PQ and QR, and if I sum up PQ and QR, then it is the shortest distance, right? If distance of PR and PQ plus QR will be equal.
1 minute. Can you repeat your question?
Yes. The line is PQ. Sir, can you slide up?
Okay, fine.
Yes, it's okay. Yeah, the line is PQR, right, sir? So if I calculate the distance P and R.
P and R.
Yes. And equate it with PQ plus QR.
PQ
plus QR. Then will it work?
Yes, this will also work. Like you are saying, suppose then you should know, like basically you should know where R is and where P is and where Q is. Okay, so because then here order matters, right?
Oh, that's why I didn't get the answer.
No, see what my point is. Suppose you have this is suppose your x axis. So you have a point P here, you have a point Q here, you have a point R here. Okay. So you calculate PQ, you calculate QR, you calculate PR. So what is your next step? What you want to do with PQ and QR and PR?
Oh, I have assumed that PQ are in order.
Okay, if it is in order, see that order is also not a problem. So if you can show, suppose they are not in a order, right? Suppose they are not in a order. If you can show that PQ is QR plus PR or QR is basically PQ plus PR.
Rest other two.
Or
yeah, it's 3 times.
PR is basically whatever the rest two.
Yeah,
if you can show that's these three number that they satisfy, if they satisfy one of this condition, then certainly they cannot form a triangle, because you know, right, in a triangle your sum of two sides is always greater than sum of the third side, right?
Yeah, I didn't get it, sir.
No, in a triangle,
yes.
If you take two sides, AB plus BC, then it should be greater than SC.
Yeah.
Right? This is true for any two side. Instead of AB plus BC, you can take AB plus SC also.
Yes, any two pair of sides.
Yeah. So but if you are taking the distance here, and if you are getting this kind of relation, okay, so then certainly they cannot form a triangle, right?
So maybe I am just considering this third. I am considering only one. That's why it will be.
No, see, if you are taking in a order, okay, so if you are taking in a order, see, first of all, you don't know the order because you don't know whether these 3 points they form a triangle or not. Okay. So you are starting. So you are starting from the beginning. Suppose you don't know well in which order they lie on that straight line. You simply calculate PQ and QR and PR, and you try to relate, try to check whether they satisfy these 3 numbers, they satisfy these 3 condition or not. If they satisfy one of these conditions, then certainly they cannot form a triangle. Is it clear now? What
Yeah,
I'm
yes,
trying?
sir. Yes,
Okay.
it's clear. Thank you.
Thank you.
ஆமா இல்ல
Syed Yusuf.
மாயா அனுப்பணும் அப்படின்னா மாயா பழகி போட்டோம் நான் சொல்லிட்டேன்.
Syed, are you here? Syed Yusuf. Okay, so any other question? So any of you have some question from week 2, you can ask now. Like,
கலந்து போக சொல்லிட்டேன் நான் பேசுறேன்.
or also you can ask from week 1 also, it is fine.
Sir, can I ask from graded assignment 1?
Graded 1, yeah.
10th question, sir.
Graded question number?
10th.
Question number 10.
Yes.
Yes. So what is your problem here?
Sir, actually, I didn't get the answer, sir. I tried, but
So you have 3 sets.
yes, sir.
So the set A is basically the set of all natural number.
No, sir, I am not talking about this question, sir. Graded assignment 1, 10th question, sir. Venn diagram.
Question number 10, right?
Yes, sir.
This is, so I'm talking about question number 10, right?
Sir, Venn diagram 1, X, Y, Z.
Yeah. Oh, Venn diagram X, Y, Z.
Yes, sir. Graded assignment 1, 10th question.
10th question.
Yes, sir.
Okay. Just a minute. Yes. Yes. Sorry. Yeah. So you have three set X, Y, and Z. So can you accept whoever who actually asked the question? Others, please mute yourself. Otherwise, I will remove him.
Sir, everyone is muted.
Okay, fine. So you have three set.
Yes, sir.
And for a set A, we are denoting the complement as A complement. So, so you have this diagram. X, Y, and Z, right?
Yes.
And from this diagram, you need to compute complement union Z complement intersection U whole complement, right?
Yes, sir.
So this is your U. U basically is your universal set, right? So whole thing is basically U. So we'll do it one by one. So X intersection Y. What is X intersection Y?
So the common area between X and Y.
Yes. So this is your X intersection Y,
Yes.
right? Then what you need to compute? You need to compute X intersection Y complement.
Yes.
So what will be your X intersection Y complement?
Sir, rest of all things.
Yeah. So your so basically except this region.
Yes, sir.
Similarly, your Z complement intersection U. What is your Z complement?
Except Z.
Yeah, this region. And you are intersecting with U. So you will get the same thing, right?
Yes, sir.
So Z intersection U is basically your Z complement intersection U is basically your Z complement, right? So now you have these two sets. We are taking the union, right?
Yes, sir.
So what we will get?
Z plus Z union X intersection Y. Oh, sorry, Z only.
So we will see the setup regions which are either in this set or in this set, right? So as you can see, this particular region, can you see it?
Yes, sir.
This is in Z complement intersection U, but this particular region is not in this set. Okay, so but this particular region is in Z complement intersection U, so this particular region will belongs to their union, so you will get this set.
Yes, sir.
And also you will get other thing.
Yes, sir.
But this region is not in Z complement intersection U, and also that particular region is not in your X intersection Y complement, this particular region.
Yes, sir.
So the union is basically all the things except this particular region.
Yes, sir.
Right. And what is this particular region is?
X intersection Y intersection Z, sir.
Z, right? So you need to calculate
Complement.
the complement of.
Yes, sir. Yes, sir. I got it, sir.
Got it, right?
Yes, sir.
Hmm.
Thank you, sir.
So any other questions?
Hello, sir.
Yes.
Sir, what is the answer of question number 9? It's B, na?
Sorry?
Sir, in the graded assignment 1, what is the question answer of question number 9? It's B, na?
Yeah, B.
Sir, but I choose that option, but it shows me incorrect.
It should be uniform. Any other person face the same problem?
No, sir. My answer is that, sir. I choose the B only. Sir, I guess that person selected the C by mistake because the marking is the.
Okay, I got your point. Like, so
Yes, sir.
marking is somehow, yeah, basically the marking
Different from
is,
others.
yeah. Suppose you have a diagram here, then option A is this. Suppose
Yes,
you
sir.
have a diagram here, then option is B. So probably you have made mistake here. So yeah, but option B is correct.
Excuse me, sir.
Sir,
I have doubt regarding 7th question in week 2 practice assignment, sir.
Practice assignment, yeah, basically maybe tomorrow Devajyoti he will take a live session regarding week 2 practice assignment, so you can ask your question there.
Okay,
so
sir, thank
do
you.
you have any doubt from activity question?
No, sir, no doubts.
Okay, fine.
Yeah, thank
Sir,
you.
Okay, thank you. Hello.
Sir, just a minute, Sajid, I have to telling that graded assignment question number 9. There is a two option.
Week 1.
Same.
Week 1.
Yes, week 1 graded 9. There is a two options, sir, and both are same.
Which
and
one?
I have chosen 9, sir.
9. Yeah, 9. 9, you have 4 options, right?
4 and two of them are just
Same. You are saying.
same.
So
Yes, and
which
I have
options?
chosen
Which
I have
options?
chosen last one and it shows correct.
No, last one is not correct.
But I have chosen that.
No, last option is not correct. Hello?
Yes. Yes, sir.
Last option is not correct, right?
No, I have chosen second. Sorry.
Yeah. Because the only option here, only correct option here is option B.
Yeah, got it.
Because see, A and B and C are disjoint. Okay. So certainly they cannot have intersection, non-empty intersection. So that's why only option here, only correct option here is option B.
Excuse me, sir.
Yes.
Sir, I am Abhishek Chaudhary. Sir,
Mm.
sir, for week 2 there is no means PDF slides, sir. Sir.
Any question you?
No, sir. This is not question. This is a query. For the lecture slides, there is no sir PDFs like that.
No, I didn't get your point. So what you are trying to say, for lectures, there is no PDF.
Sir, he's trying
Yes,
to
sir.
say that
Slides.
week 2 lecture is not shown in his email, Gmail or in its ID.
Okay. Okay, we'll check
No, sir.
that.
Week 2 is showing, but not the PDF slides. Means actually there is a portion of supplementary materials. There, week 1 is there slides, sir, but week 2 is not uploaded yet.
Yeah, I think yeah, probably I will inform him. Oh, I don't know when they will upload it. Okay, so I'll inform if there is some like yeah, if they're supposed to upload it by today, then they certainly they will. If I don't know what is the deadline for that. Okay, I don't know when they're supposed to upload it. Okay, but I will inform them. Okay, the portal team I will inform them.
Okay, sir.
So any other question from activity? Okay, so you can ask your question directly or you can post it in the chat box. Shweta Jha. Can you explain one and onto function with example? Hello, Shweta? Hello? Shweta, are you here?
Hello, sir.
Hello.
I am Dinesh.
Uh,
I have a little doubt in assignment activity question 2.5, question number 4.
2.5, question number 4.
Sir, why last option 04 is correct?
So which of the following points do lines of slope 0 pass?
Yes.
So first tell me why option 2 is correct.
Option 2. Yeah, because it's on x-axis.
Option 2 is on x-axis.
No, sorry, option 2. No, I have
Question number 4, right?
Yes, question number 4.
So you have a doubt in question option 4. In question number 4, option 4. Okay.
Oh, I did not get yeah. You have said option 2. I have not chosen that. I didn't get it. Does it have zero slope, sir? Option 2 has zero slope.
The question what first try to understand the question. This question is asking, so you have 4 points here. Okay, so the question is asking whether there is a line which passes through these points and that slope of the line is basically 0. So you have origin here, right? And x-axis, basically your x-axis passes through origin, right? And slope of that line is what? 0.
Yeah.
And you have another line minus 100 0.5. Suppose this is your this point is your minus 100.5. Then you can draw a line which is parallel to x-axis, right?
Oh yes.
And the slope of that line will be 0.
Yeah.
Right. And similarly, you can do for any point in the xy plane, you can draw a line which is parallel to x-axis for any point.
Yeah, now got it.
Yeah, so that's why all the options are correct. Got it, right?
Yes, I got it.
Okay, thank you.
Okay, thank you.
So can you please explain the equivalence class thing, sir?
Equivalence?
Class.
Equivalence class.
I didn't get the partitions and all.
Okay, so do you have some specific example?
No, sir.
So you want to understand the concept, right?
Yes, yes.
Okay. So okay, so let me start with an example, then I will come to so from that example, I think you can understand what do you mean by that, how actually equivalence class will create a partition on that set. Okay, so suppose you take set up numbers. Suppose I'm taking 1, 2, 3, 4, 5, So here what I'm defining a relation R. So what is my relation? A is related to B if your A minus B is even, right? So can you tell me whether this relation is reflexive or not?
No, sir.
Hello?
No, sir.
Hello?
Hello?
Huh?
No, sir.
So no.
Yes.
Why?
Sir, if we take like reflexive, sir, reflexive is if we take 1, 1, if we minus 1, then it will give us 0. Is 0, are we considering 0 as even, sir?
0 is even.
Okay, sir. Then it is reflexive.
0 is even. So as you can see, A comma A
Yes, sir.
is basically in R because A minus A is 0 and 0 is even, right? Next, your symmetry. So next thing is whether this relation is symmetry. Hello?
Yes, sir.
Huh. So can you tell me whether this relation is symmetry or not?
Yes, sir, it is symmetry.
Because if A minus B is even, then basically if A minus B, which is K, is even, then your B minus A, which is basically minus K,
Will be even. Yes, sir.
is also even,
Yes,
right?
sir.
So now you have this relation is symmetry, sorry, reflexive, symmetry. The next thing is
Transitive.
transitive. So whether this relation is transitive?
Yes, sir.
Yeah, because you have suppose A minus B is even and B minus C is even. Then if you add A minus B plus B minus C, then A minus C is also even, right?
Yes, yes, sir.
So then your A comma C is also in R. So this is transitive. So now this is a equivalence relation. Okay. So now you have a equivalence relation on this set X. So now what we will do, we'll try to form some different type of sets. So first what I will do, so I'll take, so you have this X, basically 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now what I will do, I'll pick one element. Suppose I pick one. So I'll try to find out all the elements for all the elements in the set X such that one is related to A, right? So my set, suppose I denote this set, suppose some B1 is what? X in X such that X1 is related to X. So can you tell me what are the elements of B1?
Sir, 1, 1, 2, 2, 3, 3.
No, B1 is not, the elements of B1 are not in the form of tuple, because elements B1 is basically a subset of X. See how I defined B1. The elements in the set X which are related to 1. So we will go one by one, right? So 1 is related to 1.
Yes, sir.
Because 1 minus 1 is 0.
Yes, sir.
So 1 is there. Next, whether 2 is an element of X.
Yes, sir.
How?
2 minus 2 is 0.
No, see the condition, you see the condition.
Okay, okay, sir.
We are taking all the elements of X which are related to 1. Okay, not to himself. Okay. We are taking all the elements which are related to 1. Here 1, that's why I mentioned all the elements which are related. So now you tell me 2 is a member of V1 or not?
No.
Hello?
Hello.
Huh? So 2 is a member of V1 or not?
No, sir.
Because 2 minus 1 is 1,
1
which
is 1.
is,
Yes, sir.
yeah. So 2 is not a member of B1.
Yes.
You can see 3 is a member of V1.
Yes, sir.
4 is not a member of B1. Okay. So if you keep doing this, then you can see all the odd numbers.
Yes, sir.
3, 5, 7,
9.
9. Now you take B2. What is B2? Such that X is related to 2.
Okay.
So now can you tell me what are the elements of B2?
Sir, 2. All the evens, sir.
Yes. So basically, as you can see, B1 and B2, they are disjoint. Can you see it?
Yes, sir.
See, because why? Because you have B1. B1 is set of all elements which are related to 1.
Yes, sir.
And you know 2 is not a member of B1.
Yes, sir.
Okay. And B2 is what? B2 is the set of elements which are related to 2. So suppose there is a member X belongs to B1 intersection B2. Then X is, by the definition of B1 and B2, X is related to 1 and X is related to 2. Right? Hello?
Yes, sir.
So then, but you know your reflection, your relation is transitive.
Yes, sir.
Okay. So then you will get 1 is related to 2, but this is not possible, right?
Yes, sir.
So that's why your B1 intersection B2 is empty. So can you tell me, is there any element which is not a member of B1 and or not a member of B2?
No, sir.
So we got all the elements, right?
Yes,
there is no element left in the set X which is either not in B1 or not in B2.
Yes.
So basically what you are getting, we are getting a partition of B1, partition of the set X, which is basically B1, and another set is B2.
Yes.
So suppose you have some relation X. Suppose now I will come to, so you got so is it clear, this example?
Yes,
whatever sir. So now you got you got an idea how basically it's working, that equivalence class, basically how it is creating a partition.
Yes,
okay,
sir.
so suppose you have a set X. Suppose you have some element A1, A2, AN, Okay, and you have a relation R on X, which is a equivalence relation, right?
Yes, sir.
So what you do now, you take A1. Okay, from that you create a set B1. And what is B1? B1 is basically the set of elements in the X
Related to 1.
which is related to A1.
Yes.
Suppose if you get all the elements of X, okay, in the set B1, if you got all the elements of X, then basically your B1 is basically a partition,
Yes.
right?
Yes.
Partition of X1. That partition is basically sorry, not X1, X. That partition is basically X is equal to B1.
Yes,
Is it clear what I'm trying to say?
yes, sir.
First, you take an element from the set A1 and you try to construct this set B1. And what is the elements of B1? B1 contains all the elements in the set X which are related to A1. So
Yes,
if you get all the elements of X in B1, then you are done, because B1 is basically a partition of X. Suppose B1 is a proper subset of
X.
X, then you must have some element
Left.
An, so not An, you suppose you have some element AK, which is not a member of B1, right?
Yes.
Now you construct BK. And what is BK?
All elements.
Now you can see B1 intersection B2, B1 intersection BK
BK.
is empty, right?
Yes. Yes, sir.
Because if there is a element is there in BK and also that same element is in BK, then using the transitive property you will get that your A1 is related to AK. But we are assuming something different. We are assuming that AK is not a member of B1.
Yes.
Okay, so you can do similarly. You can keep doing. You can take some other element which is not in B1 and also not neither in B1 nor in BK. You can, if there is some element. Okay, so you can keep doing like this, right? Hello.
Yes, sir. Yes, sir.
So eventually what you are getting, you are getting, so if you keep doing like this, then you can write your set X as B1 union B2 union B3, right?
Yes, sir.
So, and you know this by our construction, your B1, basically your BI intersection BJ is empty, right?
Yes, sir.
So this basically is creating a partition of the set X, right?
Yes. Yes, sir.
So is it clear now?
Yes, sir.
Okay. So here basically, yeah, that equivalence relation, that whatever, that actually plays a crucial role here, because from that only you can say that BI intersection BJ is empty.
Yes, sir.
So any other question?
No, sir. Thank you.
Okay, thank you.
So just a general question, sir.
Hmm.
Sir, I didn't submitted my graded assignment one, sir, because I have actually got my hall ticket for the last qualifier. So is it not? It is not mandatory, no?
Sorry, I didn't get your question.
Sir, I got my whole ticket in the last qualifiers. So is it mandatory to submit a graded assignment for this qualifier?
I don't know actually. Can you send this mail to that support @ online degree iitm.ac.in?
Okay, sir. I will.
Okay. So anybody have some other questions? Hello.
Hello, sir.
Huh?
Sir, this is Mrityunjay. I have a query regarding graded assignment 1, question number 7.
Question number 7.
Yes, sir.
So what is your problem?
Sir, I have selected the answer for this question. F is neither one-to-one nor function is neither one-to-one nor onto. So actually, before giving graded assignment 1, I gave the practice assignment 2, and in that assignment there is a question similar to this one.
Yeah. True.
The right answer there was function is neither one-to-one nor onto. So based on that, because my function and the relation topic is not that clear. Okay.
Yes.
So I gave the answer based on the answer I got in practice assignment 2, but it is wrong here.
Yeah, certainly it
how
is
is
wrong.
So can you please?
Yeah. So basically you have a function here.
Yes, sir.
Some set of all material, and you have dielectric constant. So they assign some value, some number to all the materials. So then you can construct a function from all the materials. So now first try to write the function. You have the function from air and vacuum, and some other things are there to the set 1, 3, 6, 7, 12, right?
Yes, sir.
And the dielectric constant of air is 1. So F of air is 1, and dielectric constant of vacuum is also 1. Six. Right? So this is your function.
Yes, sir.
So first tell me whether this function is 1, 1 or not.
Sir, it is 1, 1.
Why it is 1, 1? Okay, then before that tell me what is the
No, sir. It is sir.
What is the
It is
definition
many
of
to
1?
1 actually.
Yeah,
So 1, 1's definition is for every member in set A has to be
suppose you have a function from A to B.
Yes.
So what then when you will say that this function is not is 1, 1?
So for every element in A has to be an unique element in B, mapped to unique element in B.
Yeah, so
then it will be called 1 to 1.
No, what do you mean by like unique means no, what do you mean by, can you explain it little further?
So for like in this question, it is given that for air, it in dielectric constant, it is 1. And for vacuum, the dielectric constant is also 1. So both the function is giving similar value in dielectric constant.
Yeah, basically two
so
different.
It is many to 1, I guess.
Yeah, two different element in A cannot have same image, right?
Yes, sir.
This is basically the definition of 1, 1. If you have two element in the set A and x1 is not equal to x2, then your f of x1 cannot be equal to f of x2. If f satisfy this condition, then you will say f is 1, 1, right? Hello?
Yes, sir.
So as you can see,
yes,
here
sir.
You have air and you have vacuum, but the image of air and vacuum both are same. So this function is not 1, 1.
Yes.
So what about onto? Whether this function is onto or not?
For onto, it has to be for every element in set B has to be a pre-image in set A.
Exactly. Take any y in B, there should be a element x in A such that
in A
f of x is basically y, right?
Yes, sir.
So now what is so here B is 1, 3, 6, 7, 12, right?
Yes.
So for 1,
yes, sir,
you have air. If you take air, then a image of air is basically 1. So 1 has a pre-image.
Yes, sir.
Right? Similarly, the pre-image of 3 is paper. Similarly, you have pre-image for
paper.
Yeah, pre-image of 3 is paper. Okay, and similarly you have pre-image
Yes, sir.
for 6, 7, 12 also, right?
Yes, sir.
Because 6 has a pre-image that is proclaim, right? And 7 has a
Yes, sir.
pre-image and 12 has also a pre-image, right? So then each element
Right, sir.
of B has a pre-image in your
In A.
in A. So then this function is onto,
Yes.
right?
On to.
So
Right,
that is why this basically, yeah, your third option is correct. F is onto, but this is not a 1-1 function.
Okay. So in question number 9 in graded assignment 1, I have selected
So yeah, like, is it clear
option
now
B.
why the third option is correct?
Yes, sir. Yes, sir.
Okay.
Yes, sir. Bilkul.
हाँ.
So actually in question number 9, I have selected option B as an answer, and it is given as the incorrect answer. But in accepted answer, they have given answer option B actually.
No, I think you
So
have
I
made yeah, one of other student also told me the same thing. See, the you should, like, yeah, basically if you see the question, so the format is you have a option here, okay, and that
yes
you have to select the whatever that thing is there, that basically the circle is there below that option. Okay, so this circle actually represent this option. Okay, and this circle represent this option. Probably you have selected some other I will, yeah, basically I think you have selected the first option. You have selected this
Okay,
option.
so the diagram is above the checker box actually.
Yeah.
So I was trying to select B, but I selected A.
Yeah. Actually, there is there is some problem in LaTeX. Basically, yeah. So that's why the circle is coming below the diagram. Okay.
Yes.
Yeah, option B is correct.
So I watched all the videos uh, in week 1, but I'm having some problem in actually a relation and function topic. So can you suggest me any ideas from where I can clear it up, and is it going to be create more problem in further weeks like week 2 and 3?
Definitely. See, I think the most important subject for this course, I think, is this relation function 1-1 and on.
Yes, sir.
So you are going to see all the things probably in each and every week. Okay. So these things are
So
quite.
I have tried.
Hello.
Actually, I have tried. I have tried to clear these doubts from other sources also. The surjective, bijective, and injective. These 3 topics are creating some problem, because there are other functions, several functions in which I have to check whether it is bijective, whether it is surjective or not. And for that matter, maybe I need some more sources. Can you suggest me any solution
See,
for this?
thing is, I can suggest, like, you should try to solve more questions. Then only see, like, then only you can clear your doubt. Okay, because reading, see, you know the definition of 1-1, you know the definition of onto, you know the definition of when a function will be bijective. You know everything, right? Okay, but
Yes,
the
sir.
thing is, you don't know
Yes,
how
sir.
to implement it. Okay, so for that I will suggest try
Yes,
to
sir.
solve more questions. See, once see, for a particular questions, you suppose you have a question f of x is equal to x square. Okay, so you, to check whether this function is 1 or on 2, you have to use some different method, where to check this function is 1 or on 2, you have to use some different method, because see here you should know like what you are going to do when a x square term is coming. Okay, you should know what you should do when a x term is coming. Okay, so to deal with this kind of thing, you have to solve more questions. Okay, you already know the definition, so don't try to read the definition.
Yes, sir.
If you like, you are convinced that okay, I know the definition, then I will suggest try to solve more and more questions. So this particular, I think you can get from any some entrance book for this +2 exam. So
okay,
so I think that yeah, if you
maybe
try to
for NCERT, if someone is suggesting me to do questions from NCERT.
yeah, NCERT also, I think that is also fine. Then there are so many questions in NCERT, but still if you want more, then you can go to some first. I will suggest, see, the week 1 is quite important. Okay, so first try to clear the concept of week 1. Okay, don't neglect it, otherwise it will create a problem later.
Okay, sir.
Okay,
thank you, sir.
Thanks. Hello, Prapti. Hello. Hello.
Hello.
Huh.
Good evening, sir.
Yes, good evening. So, what is your doubt?
Sir, have you discussed question 2? Sir, actually, I've joined a bit late due to my college classes.
Question number 2. In what, like activity, graded, practice?
Graded assignment.
Week 1, right?
Week 1, yes, sir.
So what is your problem here? Like,
sir, how is it A equal to B, sir? That is my problem, sir. That option I didn't get it. After solving it, I didn't get that. I didn't come to that conclusion.
So what? So what you got? Like in the end, what you got?
Sir, I got it as the B is a proper subset of A. So that is the answer I got. So
No. What I am saying, you have this equality, right?
Hello. Yes, sir.
So okay, so if you solve, if you try solving this, then in the end, what you are getting?
So I'm coming to the I'm getting that B is a subset of A.
No, not conclusion. I'm not asking about conclusion. So if you compute this, so if you simplify this expression, what you will get in the end? This expression and this expression.
Sir, I'll get so left side it is A union B.
A union B, yes.
And sir, right side it is
A intersection B.
Yes, A intersection B.
So from this, you want to conclude that how A is
yes,
equals.
sir. How A is equal to B, sir. Yes, sir. This is my doubt, sir. How to conclude
As
this?
far as I know, this particular thing, I think sir discussed in his lectures. Okay, so okay, let me solve it. Okay, you can see the video lecture. Like I think he solved it in one of the lectures. So so you have So now you want to say that, so sorry, you want to show that A, basically A is equals to B. Okay.
Yes, sir.
So
Yes, sir.
suppose your A is suppose A is a proper subset of B.
Sir, B is a proper subset of A in this situation.
No. What I am saying, you have this thing, right? A union B is equals to A intersection B, right?
Yes, sir.
So first thing is I want to know whether this option is possible or not, whether B is a proper subset of A is possible or not. If B is a proper subset of A, whether this condition will hold or not. This is what I want to check, right?
Yes, sir.
So if B is a proper subset of A, then what you are going to get here? You will get B here, right?
Yes, sir. Yes, sir.
You
It
will
will
get
be.
you will get A here, right? And
A here.
A cannot equal to B because B is a proper subset of A, right?
Oh, yes, sir. Yes, sir.
So this is not possible, right?
Yes, sir. Not possible.
So now take whether A is a proper subset of B, whether this condition is okay, whether this relation is will hold for this particular equality. If A is a proper subset of B, what you will get here? You will get here
A, and over here we'll get B.
B,
I think.
and certainly
Yes,
B cannot be equal to A, right?
Yes, sir.
So this is also not possible, right?
Yes, sir.
So now you have, suppose B is not equal to A. Hello.
Yes, sir.
So this is for your understanding. Okay. Yeah, basically you can do this directly without involving this thing. Okay. Suppose B is not equal to A.
Yes, sir.
Then A intersection B is a subset of A. Sorry.
Yes, sir.
No. A intersection B is a subset of A.
Subset of A. Yes, sir.
And B intersection is also a subset of B.
Yes, sir.
So can you, if B is not equal to A, now can you say that whether this will hold or not? A union B.
Oh. Okay, sir. Yes, sir. I got it, sir.
Got it, right?
Yes, sir.
Yeah, because this is a subset of A and this is also a subset of B, and you have B is not equal to A. That means what? There exists a element in B such that X is not in A, right? This is what you mean by B is not equal to A, right?
Yes, sir. Yes, sir.
So then X is in A union B, right? But
Yes,
X
sir.
is not in A intersection B.
Intersection B.
So if B is not equal to A, then this is not possible.
Yes, sir.
Got it?
Yes, sir.
Yeah.
Got it, sir.
Yeah.
Bad mistake, sir. Sorry,
Yeah,
sir.
yeah, it's fine.
Thank you, sir.
Thank you. So any other questions? So anyone have some other questions? So Jayanti, so is there anything you want me to explain you with some example? I can do it. If something is not clear to you, I can solve, like I can explain you with examples.
Relations are injective and with some examples like how you did for one-to-one and on-to. That was that pre-image was very clear after you explained with the example. Similarly, if you can give some numbers or some elements.
Okay, so you know the like you want to know basically something related to one-oneness or onto-ness of a function, right?
Yeah, no, this is regarding this relation, bijective, injective, and surjective. When we read it, we are able to understand. But when it is posed as a problem, we are not able to, get it clearly. And so also this transitive property, because they give A, they give B, the question. They don't give a C, but they say it has the transitive property. So there was one graded assignment question. So where they had given only the two sets, I mean A and B, the relation. But they also said it confers the transitive property. It also is applicable for transitive. So I couldn't understand that. When it comes as a problem, I know if A equals B, B equals C, A equals C. That concept I understood. But in a real life situation or when they give problems. So basically, as you said, we need more exercises, more problems.
Yeah. Yeah. Okay. So let me. So yeah. So hello, Jayanti.
Yes, sir.
Yes. Yes. So okay. So can yeah. So are you saying something like?
No, I'm not. I'm just waiting for your reply.
Yeah. So
yeah, in
no.
fact, I also support Jayanti's suggestion. Since we have sort of an undisturbed time now, why don't we start that basic concepts of injective, subjective, and transient, and all those issues.
Yeah,
really confusing.
Yeah, yeah, like yeah, one of you actually basically asked me the same thing. Say the thing, so that is the thing. See, the problem is see, the problem is, you know what is one, you know what is onto, you know what is bijective. Okay, the main problem is when you see a problem, you when you start solving a problem, you cannot implement whatever you have read into that problem. Okay, so that is the main problem. See, the only thing I can do is I can tell you what is one, what is onto, and what is bijective, and I can give you 2-3 examples. Okay, but certainly that won't help you much. Okay, one thing I will suggest, this is the way that I actually basically learned it. Okay, when you will start solving more questions, and if suppose you are solving some question and you have doubt in that question, you can ask me. Like I can solve you where like you are facing the problem. Until unless you are not solving lot of questions, then certainly you will face the same problem. So,
like when you said about this pre-image, sir, when you get the example of the numbers, and when you don't find a corresponding thing in A, that was very clear. Till then, we understood the English part of it, but we didn't know how to apply it. But when you gave the numbers as one has one image and the other one doesn't doesn't appear in B.
Yeah.
So like that, if you are able to give us one example for this relation, maybe we'll be able to understand.
I'll give one example, but the thing is, what my point is, why I told you to solve lot of examples. So, see, whatever argument I gave there, that is fine. So if like you can use that same argument to solve similar kind of problem. Okay, but when I will give you a function something like r to r and x goes to x square, then you cannot use the same idea.
Okay.
Because here cardinality of r is infinite and cardinality of r is infinite. You simply cannot go one by one. Okay. So here what you need to do, you need to use the property of x square. Okay. You know that x square is always greater than equal to 0, right? So then you cannot have a pre-image of -1 here, because always you will get, if you will take some number, you will get positive, right? So then you cannot get the pre-image of -1 here. Okay, so that is why your f is not on 2. Okay, so for different problem, you have to use some different approach. So certainly you cannot implement the same idea for all the problems. That's why I'm saying you have to solve more and more problems. Then only you will come to know how, like, once you see the problem, then you can understand what I need to apply here.
I heard from many people, sir, they say that try plotting it on graph, sir. Can you please explain that?
Sorry?
Sir, I heard from many people about that injective surjective function. They said that try plotting on graph.
Yes.
So, sir, can you please explain the process, sir?
So the thing is, what generally you do, so your x-axis basically represent your domain and y-axis basically represent your range. So now now you try to draw a line which basically parallel to your x-axis, right? So now so this line is basically parallel to your x-axis, and throughout this line your value of y is
same.
Yeah. Now you can see at this point, suppose this point is some x1 and this point is x2. So this particular line basically cuts your graph at 2 points. So from this you can say that f of x1 is basically f of x2. So if you're first you try to draw a line which is parallel to x-axis and check whether that line cuts your graph. If it cuts your graph at more than 1 point, then that function cannot be 1, 1. And if that line cuts at 1 point, then you cannot say that function is 1, 1, because you have to do it for all the lines which are parallel to your x-axis. So you have one line here, you have another line here, you have another line here. You have to check for all the possible lines. Then only you can say that whether that function is 1, 1 or 1, 1 or not. Suppose you have a function here, this function. Okay. Now you try to draw any line. Certainly it cannot cut the graph at more than 1 point, right?
Yes.
Then this particular function
1 to 1.
is 1, 1. So this is basically the method. Yeah, whatever you have asked, you can draw the graph and using this vertical line. Sorry, horizontal line. You can say that whether this function is 1, 1 or not.
We can also deduce that onto.
Sorry.
We by doing this one, we can decide about whether it is 1, 1 or not. But can we identify onto or not?
Yeah, onto also you can say like whether this function is onto or not. That also you can say.
Oh.
Okay, let me give you an example. So suppose I'm defining a function from R to R. So now you have a suppose you have a graph. Suppose you have a graph. So this is your graph, and suppose there is some here. There is some discontinuity here. So this is from here to here. Then I am taking this. Now, if you draw a graph like this, then basically this line you are not getting. Yeah, basically this line is not actually. Yeah, there is no intersection of this line and of this given curve, right? So then you can say that for this particular point, you don't have a pre-image. So then you can say that this function is not onto. Right? Hello?
Yeah, I'm just saying, but I don't still understand. Just because it is not crossing,
yes,
so it becomes an onto function, is it?
Yes. No. This is not onto.
What is this? I requested a graphical explanation for the onto, like what you have done for on 1 to 1 and not 1 to 1.
Oh, sorry. I got your point. What you want to say? Now I'll give you two examples. One case, one is your function is f of x is equal to x square. Okay. So the graph of this function is basically looks like this. Okay. So this is your x-axis and this is your y-axis, right? So now so first thing is whatever graph you are plotting and that graph should be a function. Okay, then only you can check whether that function is 1, 1 or not. Okay, suppose you have a graph like this. Okay, and this cannot be a function, right? Because if you draw a line, then this line cuts this graph at 2 points. And you know a function is basically a relation which cannot be one to many. Here, this particular x, for a particular x, you are getting two values, this and this. Suppose this point is your a1 and this is your a2. So what you are getting, x a1, and also you are getting x a2. So this basically is a one to many relation. That is why this graph cannot represent a function. Now, is it clear?
Yeah.
This part is clear, right?
Yes.
So now if you see this particular graph f of x is equal to x square. So now if you draw line which is parallel to y axis, then certainly it cuts the graph. Any line you draw cuts the graph at exactly at 1 point. So then from this graph you can say that this graph represent a function. So now now we have to check whether this function is surjective or not. So now you try to draw line parallel to x-axis. So in each line, the value of y is constant. So you have a value of y here, and this line, this particular line cuts the graph at this point and this point. Then for this particular value, you have a pre-image here and you have a pre-image here. Now, if you take this line, this particular line, it don't have any point of intersection with this graph, right? So for this value of y, you don't have a pre-image. That is why this function cannot be onto. Is it clear?
So what I understand, if a horizontal line is not having a pre-image,
yeah,
it's an onto function.
Yeah. If your function is from R to R, see, first thing is you have to represent your function in the xy plane. I cannot represent this function in xy plane, right? This particular function, whatever this particular function I cannot represent in the xy plane. Okay. some. Yeah. This particular function I cannot represent in the xy plane. But if you have a function from R to R, or maybe some then you can use you can draw this horizontal line, and you can check whether you have a intersection point with the given curve. If you have a intersection point, then you can say that whether this function is onto or not.
Okay.
So if the first thing is you must have a picture for that function, then only you can talk about horizontal line or vertical line. Okay. If your domain is discrete, then how you will draw a graph of that function? Okay. Then certainly you cannot draw the graph, right?
So how do we handle that?
No, that's so basically, see, that is the point, that is what I'm trying to say. Like, it's like for this particular question you can handle it directly, like, because your domain and codomain is finite. Okay, so then you can check one by one. Okay, suppose you have some other function, then yes, that is what I'm trying to say. If you start solving more and more questions, then you will come to know, like, how you will handle some different if you have some, suppose you have a function, suppose you take a function from Z to Z, and here your f of n is equal to, suppose, 2n. Then if you will try to draw the graph, then it is completely unnecessary for this particular question, okay, to check whether this function is on or on 2. Okay, so some question you can apply this method, but you cannot apply the same method for all the questions. Okay, so for different question you have to apply different idea, and that you can only get when you will solve more questions.
Where do we get the questions?
See, these are like, you can get from any like close to, like, for any entrance exam book, I think you can get all this type of question.
Okay.
Or maybe NCRT book.
Yeah, as you are suggesting to refer to NCRT, I just quickly browse through that. Yeah, there are some questions, and it's too early to say that it's not a right source. Give us some time, then we will try it and get back. Next class.
Thanks.
Thank you.
Yeah.
Thank you.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.